Friday, and you know what that means. Fusion with Phil. Today we'll be talking about tolerance and smoothing and how we can clean up our toolpath like the ones on my right while reducing our file size and improving finish. That top one you can see we have quite a few more points versus the bottom one that's cleaned up to the point where it's just where we have simple axis change. Let's get into it. So looking at our part here, we have a couple of toolpaths I've already generated. These are pretty standard toolpaths. We have a scallop, a contour, and then kind of a steep and shallow strategy based on the different packages that you may have in Fusion. One thing you will see later is that steep and shallow actually has some very advanced things that would justify to me if I was a mold maker or doing a lot of 3D surfacing as to why you need the machining. So let's start out with the scallop toolpath. So first and foremost, we're going to just go ahead and do a simple simulate. And for all of you wondering how I get this information, as we went ahead and turned on our toolpath, we wanted to do show points. Lastly, we're going to say all toolpaths. So what I'm actually going to do is I'm going to get rid of the links just because we're really just concerned in the dots. To say the least, the number of dots is what we're looking at and how that's going to interact with our actual machine. So in this case, if we were running a much older machine, every dot is an axis change, which is creating almost a 1 megabyte file. It's actually over 1 megabyte, but that 1 megabyte is huge when you have an older style controller. It also means that this toolpath has to do quite a bit. So if you don't have high-speed machining, you're going to notice your machine around 50 to 60 inches per minute is going to become semi-jerky and slow, no matter how fast you try to turn it up. So let's start with the basics here, right? So I'm going to duplicate this toolpath, and let's take a look at just starting with the bare minimums. And the bare minimum is going to be, for most of you, this is probably going to be set somewhere around 4/10. If you're in the metric system, that case, I don't know the conversion. However, again, tolerancing is where I always start when it comes to reducing file size. So let's start with the basic part. This part here, my customer said it's plus or minus 3. That's a good rule of thumb. Maybe I can just use 3 thou as a tolerance and hit OK. So what we're going to see right out the start is our file size is actually going to reduce pretty dramatically, right? So we went 10 times-ish more tolerance. So we allowed those points to be a little more dramatically placed. And when we simulate and look at this, we're already seeing a gigantic reduction in points. However, in some of these features, we still have a ton of points being implemented. So we can get this even further, right? We could increase our tolerance more. Our toolpath would actually smooth out. Again, for you guys looking at home, let me go ahead and turn this on in another view. So you guys can actually turn the points on down here at the bottom so you don't have to keep going into simulation. So that was toolpath version 1, toolpath version 2. Basically, in our straight lines, we've evened everything out and cleaned it up. So this time, let's go ahead and add in some smoothing. And let's see what that gets us, right? So again, is our tolerancing at the end of the day, and I'm going to draw this here a little bit, is how close those points fall on your profile, right? Well, now smoothing, on the other hand, smoothing comes in very handy because smoothing is how far we will allow those points to deviate to get them onto a cleaner path. So in most cases, I'm a firm believer, always match smoothing to tolerancing. And again, we're going to go ahead and hit OK. And once again, you're going to notice that simply by changing these couple of things, we have dramatically reduced. I'm just looking at one area here, but we see this everywhere on this toolpath, right? So we're seeing a great reduction in these points. Again, we're coming back into this corner. We're kind of just following the profile. So we're just making an arc. So when we just turned on tolerancing, and we actually not turned it on, but increased the size of our tolerance, we cut our file size by over half. Then by turning on smoothing, we actually cut that file size again by half, getting it lower and lower and lower, allowing that toolpath, again, to follow those curves and stay close within reason. So now what we're going to do is we're going to jump into a little different toolpath here. Let me clean this up. But before we do so, we're going to go ahead and jump over and talk about our upcoming on-site lunch and learn at Reynolds Machine. Just a reminder for those of you in the Ohio area, we will be doing a lunch and learn at Reynolds Machinery. Come by and take a class taught by yours truly on either April 13th or 14th, or even both days for that fact. Or you could just grab a free lunch and say hi. Thanks, guys. Okay, now that we are back, let's go ahead and get going on looking at kind of, again, the vertical walls of this part. So this base toolpath as a whole, we're just doing 40 thou step downs. Again, this is kind of a default in Fusion. We're looking at 3 thou with 9/10. Let's just go ahead. Actually, we're not going to change this yet. Let's just make that an even 4 thou as our very first thing. And again, we can see based on that 4/10 scenario, we have points everywhere. This back wall seems to be a pretty smooth curve, so we're almost overkilling how precise we're trying to be, right? So what I'm going to do is I'm going to go ahead and, again, duplicate, and let's just walk through this one more time. Again, all we're going to do is a minor change to our tolerance. I'm going to bump it up to 4 thou. From there, we're going to notice that, again, we reduce the points along that back arc, really cleaning up our toolpath more and more. One more time, let's duplicate this. And lastly, let's go into our smoothing, and let's give it a matched smoothing to what's going on. As you guys are going to see here is we're going to get this file smaller and smaller, but there's going to be a point of diminishing returns. Again, just on that backside arc, doesn't look like it likes it a whole lot. It's not going to get us much lower. I could if we forced a higher tolerance or even more smoothing. Not the biggest deal, again, because I'm going to start looking at maybe utilizing steep and shallow, and why steep and shallow smoothing is night and day difference. So for those of you asking at home, you can always go back in. You could add even more smoothing to this without changing tolerancing and possibly get that reduced even further, or you may need to look at using a different toolpath in this case. We're just kind of doing a one-fits-all on this part. So let's go ahead and jump in. Let's look at the steep and shallow strategy. Again, my boundaries are all the same. I think I'm doing a little bigger step down. We've kept this very, very standard out of the box. 4 thou, 30-degree transition. We're doing a 60 thou step down and a 30 thou step over. So to kind of even this out to what we had in the other places, we're going to go 40 and 20. I'm going to go ahead and hit OK and see what we get as a starting point. So as that calculates, you're going to notice this is going to take a minute just because it's doing all of the mold cavity in one shot. It's also using multiple strategies. However, we have one of the biggest files out of any of them, but if we were to compare our original based on our very first toolpath of scallop, very first toolpath of contour, you're going to notice that we're actually almost 2 megabytes worth of data, and then we're also almost 2 megabytes worth of data. So when we're looking at the data side of it, these actually almost even out because the parameters are very much the same across both. So now, let's go in and start to have fun with this. Let's start with just the bare basics of duplicating this toolpath for comparison purposes. And now let's reduce just our tolerance to see what we get. So again, we're going to go ahead and go to 40. We're going to see that this is actually going to calculate faster because there's fewer points in the mix. And then from there, we've actually dropped that file size by half. And it's already looking much cleaner. However, we're still getting a couple of funky motions throughout here. So just like before, let's add smoothing, right? So again, we duplicate. Only reason I'm duplicating is just for comparison reasons. But one trick here is always start at the top and work your way down. So we started with our tolerance. Let's go down to our smoothing. And what you're going to notice is we actually have completely different smoothing based on the steep and shallow toolpath. This is one of my favorite things about this is you have two options here. One is fit arcs and one is evenly spaced point. Well, what fit arcs is going to do is kind of like we talked about with the other traditional smoothing. It's going to move points to get them onto an arc or into a much more linear path. In this case, fit arcs is actually going to automatically look at that stuff and get me as close as possible to those edges and actually clean up that toolpath even more. As you guys can see here on my back wall is the key factor here is this has been reduced dramatically on that toolpath. And again, if we expand these guys out a little bit, so we went from 1.9 to 8 to now 3.2, and we could continue to push this further and further. However, now going back and actually duplicating this, let's look at the whole idea of evenly spaced points. Well, evenly spaced points is going to come in extremely handy again, is if we're sitting here and we're making this mold and surface finish is huge, we always want to make sure that we have a spacing of points that creates a beautiful surface finish. And again, the closer we make those points or the further away we make those points determines how many points we're actually making. As you guys are seeing, this machine file now has 10 megabytes worth of data. And if I zoom in here, we're constantly changing as we go around. However, that surface finish is going to come out cleaner and better, especially on a newer machine with high-speed machining. So that kind of concludes what we have going on. I'm going to go ahead and change this one more time. I know a lot of you out there love our content. We're always open to more and more suggestions on what you want to see. I know this week we kept it just very simple on some tolerancing. Go ahead and leave a comment, a like, a subscribe. Give us all the information that you want. I'm happy to make content on anything inside of Fusion. As always, have a great and outstanding Friday and go into your weekend. Get rest up for Monday morning.